In this last problem, we come back to finding limits. And again, we have some limit. We want to either evaluate if we think it exists, or we need to show that it doesn't exist. So this is limit of x and y both going to 0 of 1 minus cosine xy over x squared y squared. So here we encounter a third trick we can use to find such limits. And this trick is just substitution. So notice that x, y here, we can see it as a whole. So we can write u equals xy. Then this limit becomes limit of u going to 0, because if both x and y go to 0, then their product surely goes to 0. So the limit of u goes to 0 of 1 minus cosine u over u squared. So we just need to see if this limit exists and compute it. So what we can do here is recall the Taylor expansion of cosine u. So cosine u, as we remember, is just 1 minus u squared over 2 factorial plus u to the 4th over 4 factorial minus blah blah blah, some terms that are higher in powers of u. So 1 minus cosine u is just equal to plus u squared over 2 minus u to the 4th over 4 factorial plus some higher order terms. And so my limit becomes one over u squared times u squared over 2 minus u to the 4th over 4 factorial plus u to the 6th over 6 factorial minus blah 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 higher order terms, right? So my u squared would cancel with all these terms in my infinite sum. So I'm getting, there is a limit here. So I'm getting that this is the limit of u go to 0 of 1/2 minus u squared over 4 factorial plus u to the 4th over 6 factorial minus, again, higher order terms. Since u is going to 0, anything with any power of u basically goes to 0, right? These are all zeros. So I'm just left with 1/2. And so the answer would be 1/2.